Good morning, my dear students. So today we are going to learn about the new concept, which is exponents and powers. This is a new chapter I am going to start now, exponents and powers. So these are the contents in this chapter. As usual, introduction of the chapter and exponents and powers of negative integers, and exercise 6a and laws of exponents. This is very important and this is the heart of this chapter also. If you know the all the laws of exponents perfectly, you can do any problem in this chapter. This is very important. Next, exercise 6b. Next, expressing large numbers in standard form. This is also an important concept. So based on this concept, exercise 6c will be there. Next, review time, oral quiz, assignment and mental maths will be there. It's a small chapter, but it is a very important chapter. Okay, now we are going to introduction. So introduction, observe here the following table. In this table some numbers are large numbers are given. If you take the mass of the earth, it is having some 5972. After that 21 zeros are there. These many kgs. This is the mass of the earth, means weight of the earth. And if you want to read this number, it is very difficult for us to read and understand how many zeros are there. Also, first you have to count and then you have to read that number. So these type of large numbers we observe here. One more thing is speed of light. This is also after 8 zeros are there. These many meters per second. Next, mass of Uranus is also a very large number. Distance of the earth from the sun, this is also a large number. So to write these numbers and to understand and to read, we have to write them in a shorter form. Okay, shortest form. To write these numbers in this shortest form, we will use exponents. We will use the exponents. That's the main concept of this chapter. Okay, to write the larger numbers in a shorter form, we will use the exponents. Okay, that is the main use of the exponents. So next, what are the exponents? Let's see here. The exponents help in writing the large numbers in a shorter form, which we can read, understand and compare easily. So to compare two big numbers also, these exponents are used. So observe here, this is 10 lakhs, you know that. This 10 lakhs can be written as the product of 6 tens. Observe here, 1, 2, 3, 4, 5, 6. How can you write this? Observe here, in 10 lakhs, how many zeros are there here? 1, 2, 3, 4, 5, 6. So number of zeros are 6 means by multiplying 10 6 times, you will get the 10 lakhs. Okay, that you know. Observe here, 100, how can you write? 10 tens are 100, you know that. In 100, 2 zeros are there. Means we can write this 100 by splitting into 10 into 10. Okay, 10 can be written as only 10 only. Only 10, 1 10 is there here. 1000 can be written as 10 into 10 into 10 because 3 zeros are there here. 10,000 can be written as 10 into 10 into 10 into 10, which is having 4 zeros. So we can write it as the product of 4 tens. 4 times of 10. Okay, 4 times we can you have to multiply the 10 here. Here in 1 lakh 5 zeros are there, means we can multiply this 10 5 times to get the 1 lakh. Okay, now you can write this product as in a shorter form, which is called as 10 raised to the power of 6. How to read this? 10 raised to the power of 6. We are increasing. Raising means increasing. Okay, 10 raised to the power of 6 means we are increasing the power of 10 to 6 times. If we increase the power of 10 6 times you will get 10 lakhs here. Here 10 raised to the power of 5. You are multiplying 5 times here. How many times you are multiplying here? 5 times. So that's why you can write 5 as the power of this number. Okay, you are writing this number in the sum upper side, nothing but the superscript of the number. If you write this number in the downside, that is called as the subscript. If you write this in the upper side like this, sum above the number, this is called as the superscript number. Okay, this is here in this maths we will call it as the power or exponent of the number. Okay, so now this is 10 raised to the power of 5. Here 10 raised to the power of 4 is nothing but 10,000. 10 raised to the power of 3 means you are multiplying 10 3 times. If you multiply 10 3 times, you will get 1000. So this is the shorter form of the 1000. This is the shorter form of the 100. 10 raised to the power of 2. Here 10 raised to the power of 1 only. That's why you are getting only 10 only here. Okay. So if you know how many number of zeros are there, simply you can write that number as the power of that 10 to indicate this in a shorter form. So this is called as the exponential form of the 10 lakhs here. This 10 power 6 is the exponential form of the, what is this? Exponential form of the given number 10 lakhs here. This 10 raised to the power of is the exponential form of 1 lakh. 10 raised to the power of 4 is the exponential form of 10,000. 10 raised to the power of 3 is exponential form of 1000. 10 raised to the power of 2 is exponential form of 100. 10 raised to the power of 1 is exponential form of 10. So like this we can write the exponential form of these multiples of 10. Okay. So this is very easy to write by seeing the number of zeros. Just that number you have to put in the superscript of the given number. So in this number, two parts are there. One is base part, another one is the exponential part or exponent part or power. So in this 10 to the power of 6, 10 raised to the power of 6, this 10 is called as the base number, and this 6 is called as the exponent. This 6 is called as the exponent or power also. Exponent or power. And this total notation is called as the exponential form. Already I wrote here exponential form. This total notation is called as the exponential form, also called as the power notation. This exponential is also called as the power notation. Okay, one more name here. So this upper side number, this is called as the power or exponent, and this is called as the base number, which is in the base. And this, in some textbooks, this exponent or power is also called as the index also. These names you have to remember here. This is base, this is exponent or power, and this exponent or power is also called as the index also. In some standard textbooks in higher classes, it can be written in the form of index also. And this total expression is called as the exponential form or power notation. Okay, here these are the exponential forms, and you are writing here only tens, hundreds and thousands only. If a normal number is given like this 1024 or 562 like that number how can you write in the form of exponential form? Just you have to convert that number in the form of the product of prime factors. You have to find out the prime factors of the given number. Now I will show you how to write this number in the form of prime factors. Now here you observe how to write this 1024 in the form of exponential form. take the prime factorization. Prime factorization means what is the minimum prime number, what is the smallest prime number? 2. Prime number start from 2. So try with 2. Will it be divisible by 2 or not? You can check with the divisibility rules. So last digit is 4 here. You know that if last digit is 0, 2, 4, 6, 8, it can be divisible by 2 because it is a even number also. Okay. So here the last digit is 4, so it can be divisible by 2. So you can start with 2 also. 2 5s are 10, 2 1s are 2, 2 2s are 4 here, 2 2s are 4, 2 5s, 2 6 here, 2 1s, 2 2s, 2 8s are 2 64s, 2 32s, 2 16s, 2 8s, 2 4s, 2 2s. Now you count 1 2 3 4 5 6 7 8 9 10 times you are writing. So 1024 is nothing but 2 into 2 into 2, like this. You are writing how many times? 10 times. Okay. So this can be written in the form of 2 raised to the power of 10. How many times you are multiplying this 2 here? 10 times. So now you can write this in the form of exponential form as 2 raised to the power of 10. So like this you can write any number in the form of exponential form. I will show one more number also here. So to write the 3125 as the exponential form, here the last digit is 5, it can be divisible by 5. So after 2 it cannot be divisible by 3, that's why I am using 5 here. Okay, so 3 plus 1 4, 4 plus 2 6, 6 plus 5 11, 11 is not divisible by 3, so it is not divisible by 3 also, so I am using 5 only. Because the last digit is 5, it can be divisible by 5. So 5 how many times here? 5 6 are 30 here, 5 2 are 10, 5 5s here, 5 125 times, here 5 25 times, here 5 5 times. How many times? 1 2 3 4 5. So now what is the exponential form of 3125? 5 raised to the power of 5. Simply you can write this in the form of 5 raised. No need to write 5 times and multiplying with into like that. So this is the main advantage of writing the number in the form of exponential form. It's very easy to write. No need to write this 5 to the power of 5 in the form of 5 into 5 into 5 into 5 into like that. So observe here in this problem you have to write 10 times, but I wrote this in the shortest form, which is 2 raised to the power of 10, which is very convenient form. So these are the exponential forms. Okay, writing the given number in the exponential form will shorten the number, and we can read that number also very easily. Okay. So if you take one more number also, I will show you. If you want to write 540, so if last digit is 0 means you can divide this with 2 directly, a smallest prime number. So 2 2s are 4, 2 7s, 0 here, 2 1s, 2 3s are 6, 2 5s. Now it can be divisible by 5 only. So 5 2s are 10, 5 7s. Now it can be divisible by 3 only. You know that 3 9s are 27. Here 3 3s are 9. Observe here more than 2 factors also you can write this. So 540 you can write this in the exponential form of, here observe here 2 into 2 into 5 into 3, how many times you are writing? 3 times. So now you can write up to here this 2 raised to the power of 2, because 2 times you are multiplying. 5 is only 1 time. 3 you are multiplying 3 times. So 3 raised to the power of 3. So this is the exponential form of 540. So no need to write the given number in the only with the power of one number only. You may have to write that number in the form of 2 or more numbers also you have to take like this. Okay. So this is the writing the given number in the form of exponential form. If you see our video here, so this is the example I explained. One more thing, one more concept on the exponents is exponents are also used in writing the expanded form of large numbers also. You know how to write the given number in the form of expanded form like this. Already you know that how to write this in this form, but it is very big number, and to write this number also it will take so much of time, and you have to count the number of digits and you have to count the number of zeros like this. Okay, so to write this number in a shortest form, you know how to write this number in the form of exponential form. See how many digits are there here, how many zeros, 9 zeros. So now we can write this in the form of 10 raised to the power of 9, 10 to the power of 9 here. This is 2 into 10 to the power of 9 up to here. Next, if you take plus this number 4 into 10 to the power of 8 here. Okay, this is over. Next, this can be written 5 into 10 to the power of 7. This 6 into 10 raised to the power of 6. This 7 into 10 raised to the power of 5. Simply you can write like this. 2 into 10 to the power of 4. This is 8 into 10 to the power of 3. This is 3 into 10 to the power of 2. This is 9 into 10. Okay, this is 9, not 3 here actually. This is 9. Next, this is 5 into 10 to the power of 1. Okay. 10 to the power of, this is 5 into 10 to the power of 0, not 1 here. Why I am writing this 10 to the power of 0, I will tell you later. Okay, so this is a, while you are learning the laws of exponents, you can learn why you are writing this 1 as 10 to the power of 0. Okay, so now this is the procedure to write in the exponential form of the given large number in the expanded form. Okay, how you can write the expanded form by using the exponential form? This is the procedure. Just in place of these numbers, we have to write them in the form of exponents. Okay, this is very easy to write also. So next, powers of negative integers. Already you know that in the integers, if you multiply even number of integers, even number of negative integers, that also not positive integers. Positive integers, if you multiply any number of integers, you will get only positive number only. You will get the positive number. If you multiply, for example, plus 1 into plus 1 into plus 1 into like that, if you multiply any number of positive numbers, you will get the plus only, because plus into plus 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 into plus plus only will get. Okay, if you want to multiply the negative integers like this, minus 1 into minus 1 into minus 1 into like this minus 1s, if the number of negative numbers are even in number, even numbers means 2, 4, 6, 8 like that, even numbers, always you will get the product as a positive only. Okay, always the product will be positive only. If the number of integers are in the form of odd number, you will get always negative number. Okay, observe here, how can you find out this? You know how to write these numbers in the form of exponential form. Observe here, how many numbers are here? 4 numbers. So this total expression you can write simply in the form of minus 1 raised to the power of 4. Observe here, what is this power? This is even number. Now you can define this. If the power is even number, it will always get positive number. If the power is odd number, means 1, 3, 5, 7, 9, 1, 3, 5, 7, 9 like that, always you will get like this negative only. If the power is odd number, you will get negative number. If the power is even number, always you will get the positive number. You see here, minus 1 to the power of 1 is minus 1 only. Because 1 is the odd number, you will get negative 1. So minus 1 to the power of 2 is, you are multiplying minus 1 2 times, you will get plus 1 here. Because 2 is even number, just simply you can write plus 1 only. Okay. Next, minus 1 to the power of 3 means Since 3 is odd number, you will get minus 1. Minus 1 to the power of 4 means you are multiplying 4 times. Since 4 is even number, you will get plus 1. If it is 5, this is odd number, you will get minus 1. If it is 6, it is even number, you will get plus 1. So like this, for example, if it is minus 1 raised to the power of 99, observe here 99 is the odd number. No need to multiply minus 1 99 times. Just see this. What is the power here? Odd number. Odd number means you will get minus 1 only. Okay. If it is minus 1 to the power of 98, 98 is the even number. Since 8 is the even, okay, last digit is 8 is even number. This is the even power. If the power is even, you will get plus 1. Okay, simply you can tell like this. So this is the powers of negative integers. How to write the product of negative integers? Just by seeing the power. If the power is odd number, you will get minus 1. If the power is even number, you will get plus 1. That's what I wrote here. Minus 1 to the power of odd number is always negative 1. Minus 1 to the power of even number is always positive 1. Okay, positive 1 you will get. Here, just for example, we are taking 1 here. In place of 1, you can take any number, minus 3, minus 4, minus 5, minus 11, any number you can take. That product, after multiplying, which sign you will get decides this number. After multiplying that number, which sign you will get decides this number. Okay, which sign you will get now? This is odd number here, 5. After multiplying minus 3 5 times, you will get minus only because this is odd number. Then you have to multiply 3 5 times and you have to write this product. So that is the answer. Okay, if you are writing minus 9 raised to the power of 7, observe here which sign you will get after multiplying minus 9 7 times? Minus only because 7 is the odd number. So minus. Next you have to multiply 9 7 times and you have to write that product here. Okay. So first you have to decide which sign you will get after multiplying just by seeing the power. So that is the concept here. Powers of negative integers concept. Okay. So this is very important concept. You have to remember. Any negative number to the power of odd number is always a negative number. Any negative number to the power of even number is always positive number. Okay. That's we have to remember. So some example problems you see here before going to the exercise. So write the base and exponent of each of the following. So minus 6 raised to the power of 3 means what is the base here? This number is the base number. 3 is the exponent. You know all of it. Here 3.5 raised to the power of 5 means base is 3.5. The exponent is 5 here. Okay. And 7 raised to the power of 11 means base is 7. 11 is the exponent. Minus 2 raised to the power of 6 means base is minus 2, including sign you have to tell. Base is minus 2 and the power is or exponent is 6 here. Okay. So next, express each of the following in the exponential form. See, these are not the multiples of 10. Normal numbers are given. Now what you have to do to find out the exponential form of the given numbers? You have to take the prime factorization. This is not LCM. Observe here. LCM, while you are finding out the LCM of 2 or more numbers, you will use this prime factorization method. That's why they are looking like that. But this prime factorization is not an LCM. You will use this method to find out the LCM. Okay, that's why this is different with LCM. You are finding out the prime factors of the given number only. This is called as the prime factorization of the given number, not an LCM. Okay, so after finding out this by dividing with 2, while you are finding out the prime factors, you have to start with the smaller prime number 2 first. If it is divisible by 2, continue with 2 only. If it is not divisible by 2, you have to go to 3 like this. Because this 243 is not divisible by 2, you are dividing with 3 here. So you may have a doubt that from which number you have to start. You have to start from 2 first. If it is divisible by 2, then you can continue. If it is not divisible by 2, you have to go to the next prime number. What is the next prime number of 2 here? 3. You know the list of prime numbers 2, 3, 5, 7, 11, like this. Okay, first you have to try with 2. If it is not divisible by 2, then go to 3 like this here. If it is not divisible by 3, then go to 5 like this here. Okay, like this you have to go. If it is not divisible by 5, directly you have to try with 7. Okay, this is the procedure to find out the factors of the given number and to write the numbers in the exponential form. So first number you can write in the form of 2 raised to the power of 7, because how many 2's are there here? Count here, 7 2's. That's why 2 raised to the power of 7. Here 5 times, 5 raised to the power of 5. Here 3 5 times, so 3 raised to the power of 5. 243 is equal to 3 raised to the power of 5. Here 540. Here up to here you can divide with 2 only. Here you have to use 5 table, because it cannot be divisible by 3 also, this number. So up to here you are using 5 here. Next you are using 3, you can use like this also. So now this type of number you can write as the product of different factors also, like this. No need to write the given number just by using only single number like this. Okay, only some numbers have the exponent form like this. Some numbers may not have like this, and they may have 2 or 3 factors also like this. Okay, prime factorization only, it's a simple prime factorization only, but you are writing these numbers in the form of exponential form by clubbing them in the form of just a power form. Okay. So this, observe here 2 you are writing 2 times, means 2 raised to the power of 2 you are writing. Here 3 you are writing 3 times, so that's why 3 raised to the power of 3 into 5 you are writing only 1 time, so just you write 5 only. So like this you have to simplify the factors. So this is the exponential form of writing the given number. Next, here this problem already is given in the form of exponential form. Now you are writing in the reverse form, that is a normal number. Just you split them and multiply. So minus 3 whole square, or minus 3 to the power of 2 means, what is the meaning of this? You have to multiply minus 3 2 times. This is minus 3 into minus 3. This minus 1 to the power of 7, no need to write 7 times, because you know how to write this number. Here minus 1 you are multiplying 7 times, means odd number of times. Odd number of times means again you will get negative, and by multiplying 1 7 times you will get 1 only. So simply in place of this minus 1 raised to the power of 7, you can write minus 1 only. If it is minus 1 raised to the power of 8, that is even number, then you will get plus 1 here. Okay, if it is even number you will get plus. If it is odd number, since it is here odd number, you are getting minus 1. Next, into minus 1 whole square, minus 4 whole square means minus 4 into minus 4. Here I am reading this raised to the power of 2 as square also. So 2 and 3, these powers can be read as squared. This 2 can be read as squared, and 3 can be read as cubed also. Simply you can read it as square and cube also. So for example, if it is 3 raised to the power of 2, you can read it as 3 square. Okay, 3 squared. If it is 4 raised to the power of 3, simply you can read it as 4 cube. Okay, 4 cube. This is 3 square. These two numbers have a separate names also like this. Why we call them as squared and cube, I will explain later. Okay, so these numbers are used in the areas of a square and volume of the cube formulas also. That's why these numbers are read as squared and cube numbers. Okay, when we go into the perimeter chapter is there, some volumes. In that chapter I will explain you. Okay, next. So now it is, you can write it as minus 3 into minus 3 means you know that up to here you can multiply minus into minus plus 3 3s are 9 into minus 1 into minus plus 4 4s are 16. Now you know how to multiply the integers. So first you have to multiply the signs and then you have to multiply the numbers. So now it is, you know that 69 the 144 and this 144 is multiplied with the minus 1 means you will get minus 144. This is the normal form of the given exponential form of the number. So if you take 3 square into 10 raised to the power of 4, 3 square means what? Multiplying 3 2 times. 10 to the power of 4 means multiplying 10 4 times, like. Okay, this is 3 3s are 9. Here it is 10,000. So 9 into 10,000 is 90,000. Okay. So now we are going to the exercise 6a. So what is the first problem here? Write the base and power for each of the following. So already you know that how to write these numbers. No need to explain also here. Just 5 in 5 cube, 5 is the base and exponent is the 3 here. So remaining number you can write yourself. Next, write the following in exponential form. Write the following in exponential form. So already I explained you how to write this. You see, minus 3 into minus 3 into minus 3, how many times you are multiplying? Count 1 2 3 4. Just you write that 4 in the exponent as an exponent. Okay, so minus 3 raised to the power of 4. Here b, how many times it is given? 15 times. Simply it is given how many times it is multiplying. It is not written in the form of into b like that. So 15 times means you have to write that 15 as the power of this b. So b raised to the power of 15. Here, observe here, these two are number, these two are x, these two are y. You can multiply the like numbers only or like letters only. Okay. So here minus 2 into 3 is minus 6. X into x is, you are multiplying 2x. So x square you will get. Okay, like this. If you multiply 4 into 4, what will you get here? 4 square. Like this, in place of 4 you are writing x here. Means x into x means you are multiplying two equal numbers, means x square. If you multiply 3 numbers like this, x into x into x, you will get x cube or x to the power of 3. If you multiply 4 numbers like this, x into x into x into x, you will get x to the power of 4, so on like this. Okay, if you are multiplying equal numbers, you will get that number as the base, and how many number of times you are multiplying, you will write that in the form of exponent like this. Okay, here x into x is x square into y, how many times you are multiplying? 3 times. So base is y here and power is 3. 3 times you are multiplying. So y cube. So now you can remove these intos and write this as minus 6x square y cube. This is in the form of algebraic expression. You know that how to write the algebraic expressions. Now here 4 you are multiplying 100 times means 4 raised to the power of 100. Okay. So this is the exponential form, writing of exponential form. Next. Express each of the following in exponential form. These are also normal numbers are given. You have to find out the prime factorizations method. Using the prime factorization method, you have to find out the prime factors. Here observe here, this number you can divisible, it can be divisible by 7 only. So for this, you may have the doubt which number you have to use. This is 2401. Okay, 2401. We observe here. 2401 means, so you know the divisibility rules of 2, 3, 5, 6, 7, 8. These numbers you know that all of you. Okay. So 2 means last digit should be 0, 2, 4, 6, 8. No 0 to 2, 4, 6. So it is not divisible by 2. 3 means sum of the digits should be divisible by 3. Sum of the digits means 2 plus 4, 6. 6 plus 1, 7. 7 is not divisible by 3, so it is not divisible by 3. 5 means last digit should be either 0 or 5. It is not 0, neither 0 nor 5. It is not divisible by 5. 6 means it should be divisible by both 2 and 3. It is not divisible by 2, not divisible by 3. So it is not divisible by 6. So next go to 7. 7, you may not have that rule in your 5th class. I will tell you what is the rule of 7 here. Take the last digit and double this number. What is the double of this number? 1 to the 2. Okay, 1 to the 2. If it is 5, 5 to the 10 you have to take. If it is 3, you have to take 3 to the 6, like that. So 1 to the 2. And now you have to subtract that 2 from the remaining number. Subtract these numbers. Okay, so you will get 238. 238. Now you can directly you can check by dividing this with 7. If it is divisible by 7, that will be divisible by 7. Otherwise we can continue this process. How can you continue? What is the last digit again here? 8. 8 twos are how much here? 16. Okay, now you subtract this 16 from the remaining two numbers, which is 23 minus 16. How much? 13 minus 6 is here 7. You are getting 7 only. Okay, so 7 is divisible by 7. 7 is divisible by 7 means this total number is divisible by 7. So this is the divisibility rule you have to remember. Just you have to take the last digit and multiply with that, and multiply that number with 2. Okay, that number you have to subtract from the remaining number and check whether it is divisible by 7 or not. Okay, so if you are unable to divide that number, you can continue that same procedure to this number also. Multiply this last digit again, 8 to the 16, and this number you have to subtract from the 23, which is 7. So now you check, this 7 is divisible by 7, so this number is divisible by 7. So take one more example for this. To remember, I would like to explain one more example of divisibility rule of 7. Here 1 7 8 2 2. If you take here, what is the last digit here? 2. 2 2 is 4. So subtract that 4 from 1782. If you subtract this, 12 minus 4 is 8 here. This is 7 1 7 7 8. This is also you cannot divide directly. So take again double of this number, 8 to the 16, and subtract this from 177. So now it is 1 here. This is 161. Okay, now again you take the double of this one, 1 to the 2. Okay, subtract this from 16, you will get 14. So 14 is divisible by 7. 7 to the 14, you know that. So this number is divisible by 7. So this is the simple rule you have to remember. Okay, so like that you can find out by using the divisibility rules, and then you have to try with that particular prime number. Okay, prime factorization you have to do. So try with 7 here, 2401. Can divide 7, 7 3 is 21, 30, 7 4 is 28, 7 3 is 21 here. Again with 7, how many times it divides? 7 4 is 28, here 6 7 9 is 63, 7 7 is 49. So 7 how many times you are multiplying here? 7 into 7 into 7, 4 times. 7 raised to the power of 4. Okay, so that's the procedure to find out the factors of prime factors of the given number. So now this also observe here, this type of numbers you can remember, and these numbers will be divisible by 11 only generally. 11 rule you know that in your previous class. You just refer your previous class textbook to read the rules of divisibility rules of given numbers. Okay, so now this number also You have to check with 2 3 uh, 2 3 4 5 6, they are not divisible, it will be divisible by 7 only, then only you can use this procedure. Okay, this is 7 raised to the power of 5, this is minus 5 raised to the power of 5. Here just ignore this minus first, just take up to here only, and after finding the factors, after writing this number in the form of exponential form, write this negative number, but don't forget to write this negative sign here. Okay, because it is a negative number, you will get minus. Okay, next identify the greater number in each of the following. Here 3 square and 2 cube is given, just you expand them. 3 square means 3 into 3 is 9, 2 cube means 2 into 2 into 2 3 times, which is 8 here. 9 is greater than 8 means 3 square is greater than 2 cube. So like that you have to, by expanding these numbers, you can compare. It's very easy for you. Just expand them and multiply and compare. This is 8 cube 6561 here, this number is the 512 here. Okay, so since 6561 is greater than 512, 6561 is belongs to 3 to the power of 8, therefore 3 to the power of 8 is greater than 8 cube. So like this you have to multiply and compare. So see this last number, this is already I told you, this is the power of negative numbers. So here what is the power? 71 is the odd number, so that's why you will get here minus 1. Here 40 is the even number, so you will get plus 1. So in between minus 1 and plus 1, which one is greater? Always positive number only greater. That's why this minus 1 power 40 is greater than minus 1 to the power of 71, even though it is a bigger than this. Observe here, this number you will get plus 1. This exponential form you will get for this minus 1 only. That's why even though it is lesser than this number, this will be the greater than this number. Okay, next simplify. Here also just you have to multiply by expanding them and find out the product here. That itself already I explained you some problems here. You can pause this here and write the problems, otherwise you can try yourself only. Next, evaluate the following. Here also observe here, in between plus signs are given, means after expanding them and multiplying them, you have to add them like this. One problem I explain. So 3 square means 3 into 3 plus 2 square means 2 into 2 plus 4 square means 4 into 4. 3 3s are 9 plus 2 2s are 4 plus 4 4s are 16. By adding them you will get 29. So like this, all these problems you have to expand and multiply and add them. If it is subtraction is there, you have to subtract them. So next one, these are important problems. So find the value of x when 3 raised to the power of x is equal to 729. 729. Observe here, what is the base here in the left hand side? 3 here. So definitely this also will be the a number which is formed by the power of 3 only. That's why this problem will be given. Okay, so now we have to try with the 3 to write this number in the form of exponential form of the power of 3. So if you divide this 729 1 2 3 4 5 6, so it will give the 3 raised to the power of 6 here. Okay, 3 raised to the power of 6. So now you can compare these two numbers. Observe here, both the numbers, the base is equal, means automatically this exponents also will be equal, because it is an equality symbol. These two numbers are equal. Here you don't know this x value, this is unknown value, but here it is equivalent to this 3 to the power of 6. That's why the powers will be equated. You have to equate these powers. Now x value how much here? X is equal to 6. So like this you have to find out the x value here. Okay, so see the base here and convert the given number in the form of which is having the same base in the left side, and compare the exponents. It's very simple. Okay, it's very simple. Observe here, it is the base is minus 5 to the power of x. Here it is some number, it is which is given. The last digit is 5, means it is exactly divisible by 5. So you can find out the powers of 5 here like this. By dividing this with 5, you can find out the prime factors. Okay, now you can write it as minus 5 to the power of 7 because it is divisible by 5. Just I have ignored this minus and first have found, and then you can put the minus signs like this. Okay, now it is minus 5 to the power of 5, means minus 5 to the power of x is equal to minus 5 to the power of 7, means here the bases are equal, means you can equate the powers. So this is a rule also in the exponents. If the bases are equal, powers will be equal. And also one more rule is there, if the powers are equal, you can equate the bases also. Okay, you can equate the bases like this. That rule will come in the maybe in the last, okay, laws of exponents. So if the bases are equal, you can equate the powers. Okay, now take the third one, which is 1296. Here it can be divisible by 2 and 3 also, because here the last digit is 6, it can be divisible by 2. By 3 means 1 plus 2, 3, 3 plus 9, 12, 12 plus 6, 18. 18 is divisible by 3, means it can be divisible by 3 also. But we are taking only 6 because here the base is 6. That's why we are dividing this with directly with 6 to find this number in the form of the power of 6. Okay, that's one thing you have to remember here. So how many times of 6 here? 4 times. So x to the 6 to the power of 4 here. So that's why x will be the value of 4 here. 6 to the power of x is equal to 6 power 4, means bases are equal, equate the powers, which is x is equal to 4. So like this you can find out the x value. Next, find the reciprocal of each of the following. You know how to write the reciprocal of the given number. But simply you know that what is the reciprocal of 3, 1 by 3, what is the reciprocal of 1 by 3, 3. Just you have to take the inverse of this. Okay, multiplicative inverse of this you have to take this. Okay, if it is given just in the form of powers, just you have to write that power. After taking the reciprocal of this base, you have to take the power to the same number. So what will be the reciprocal of 3 to the power of 5? First you take the reciprocal of 3. What is the reciprocal of 3? 1 by 3. And then you have to put the same power to this one. So 1 by 3 to the power of 5. So like this. So what is the reciprocal of 3 to the power of 5? We can write this is 3 whole to the power of 5. What is the reciprocal of 3? 1 by 3. Keep this in the bracket only, and just you take the same power to this one. So this is 1 by 3 to the power of 5. Next, if you take minus 7 raised to the power of 11, what is the reciprocal of 7 here? First you write this, minus 1 by 7. Okay, now take the same power to this one. Simple, which is the reciprocal of minus 7 to the power of 11. Next, 1 by 2 raised to the power of 3. So 1 by 2 means what is the inverse of this? 2 only, which is 2 by 1. 2 by 1 means 2, so 2 cube. So 2 cube is the reciprocal of 1 by 2 to the power of 3. Okay, simply you can take 2 cube also, no need to write this step, just for understanding I wrote here. Next, reciprocal of minus 2 by 5 means what is the inverse of this? Minus 5 by 2. Take the same power, which is to the power of 4. Minus 5 by 2 to the power of 4. Okay, this is a simple procedure to write the reciprocal of the given number. Just reverse that number. Write the numerator of denominator and denominator of the numerator. Okay. Next, find the value of x when. So this is one more problem which is given in the previous one, like that only. But here you have to find out the factors of numerators and denominators like this. So simply you can observe this first one. This is minus 1 by 2 raised to the power of x is equal to minus 1 by 128. Okay, observe here what is the numerator here minus 1. Here also minus 1 only, no problem. Yeah, but if you take this base, this is 2, this is 128. Means you have to convert this 128 as the exponent of 2, which is having the base 2. Exponent which is having the base 2, because we have to compare these. To compare these two, bases should be equal. So by writing this 128 as the exponent of 2, you will get 2 to the power of 7. You know how to find out the exponential form of 128. Take the prime factors. 2 6 are 12, 2 4s, 2 32s, 2 16s, 2 8s, 2 4s, 2 2s. How many times? 1, 2, 3, 4, 5, 6, 7. So 2 raised to the power of 7. Now you converted this right side part. So now observe here. If you observe here, how to write this minus 1 you can write in the form of minus 1 raised to the power of 7, because since it is odd number, this will be equivalent to this number. Okay, so now minus 1 raised to the power of 7 by 2 raised to the power of 7. Since these two numbers have the same power, you can take the same power to the both the numbers, which is minus 1 by 2 to the power of 7. This you can learn in the laws of exponents in the next concept. Okay, why we are writing this in the form of this? This is a rule. Okay, if both numerator and denominator have the same power, you can take the same power to the total fraction. Okay, just take the total fraction and write the same power to the both the numbers like this. So now you observe here. So this is left hand side, which is minus 1 by 2 to the power of x, which is equal to minus 1 by 2 to the power of 7. Observe here. Now it is the base for this exponent. What is the base for this exponent? Minus 1 by 2. Exponent is x here. Here the base is also same minus 1 by 2, and the exponent is 7. Since the bases are equal, you can equate the powers. Already I told you this rule. Since the bases are equal, equate the powers. So now what is the x value here? 7. So this is the x value. So find the value of x means this is the x value. X is equal to 7. Like this, take the second problem also. This is also minus 2 by 7 raised to the power of x is equal to 16 by 2401. I am keeping this left hand side like that only. Just I am changing this to the same basis like this. So see here in the numerator, here it is minus 2, it is 16 is given. You can take this as minus 2 raised to the power of 4, because if you take the prime factorization, 2 8s, 2 4s, 2 2s, means it is 2 into 2 into 2 into 2, which is 2 raised to the power of 4. Okay, but why I am taking here minus 2 means you have to equate these two numbers. So minus 2 also, if you raise it to the power of 4, since it is even number, you will get plus 2 only, plus 16 only you will get, same plus 16 only you will get, because minus 2 to the power of 4 is also plus 16 you will get, and minus 2 raised to the power of 4 is also you will get plus 16. You are taking minus 2, because to equate these left hand side and right hand side, I am taking minus 2 here instead of taking plus 2 here. So now it is minus 2 raised to the power of 4. Now you know in the previous problems, you know what is the value of exponential form of 240, which is 7 raised to the power of 4. Now you can take the same power of these two, numerator and denominator, because these two numerator and denominator have the same power. You can take it as the same power of this total fraction, which is minus 2 by 7 raised to the power of 4. So now you know what is the RHS value and LHS value. Observe here these two by writing them side by side. Minus 2 by 7 raised to the power of x is equal to minus 2 by 7 raised to the power of 4. By observing these two, you can conclude that both the bases are equal. Therefore, exponents will be equated, which is x is equal to 4. Okay. So like this we can do this problem. Okay, listen carefully. Next one also same as this. So minus 5 by 3. Observe here, whatever the number is in the numerator and denominators, you should write these numbers exactly which is equivalent to these numerator and denominator. Powers of these numerator and denominator only you will get also. Like that only that problem will be given. Then only you can compare. Okay. So to convert them in the form of 5 by minus 5 by 3 form, you have to take the prime factors of these numbers which are having the base of the same numbers. Okay, so by taking the prime factorization of 625 we will get 5 to the power of 4 like this. 5 125, 525, 5 5, which is 5 to the power of 4, but you should get minus 5 here. That's why minus 5 I am taking here as the base here. Since it is the even number, you will get the same plus 625 only here. Okay, plus 625 only you will get, because the power is even number, you will get positive number only, which is equivalent to plus 625 only. Okay, that's why I am taking minus 5, because here minus 5 is there to equate them. Now it is by taking prime factors of 81, it will be converted into 3 raised to the power of 4. Now these two numbers have the same base. We can write it as minus 5 by 3 to the power of 4. So now you can write side by side and compare. So both the bases are equal. So now you can equate the powers, which is x is equal to 4. Okay, so like this problem. In the last problem on this one, so minus 11 by 7 to the power of x minus 1331 by 340. Here already negative number is given, so you can write directly this is minus 11 whole cube. Already you solved this one in the previous problem. So here 343 also 7 cube we will get. Both the numbers have the same power, so you can write the same power to the total fraction, which is minus 11 by 7 whole cube. Write them side by side and compare. So both the bases are equal, so equate the powers. So x is equal to 3. Okay, so now the last problem of this exercise, which one is greater, 2.7 into 10 raised to the power of 10 or 3.4 into 10 raised to the power of 12? Already while I am explaining in the introduction, to compare the larger numbers also these exponents are used. Okay, not only writing them into the shorter form, and not only writing them into the shorter expanded form, they can use it to the compare the larger numbers also. Okay, now you are comparing. So simply just you see these two numbers, you can compare directly. 2.7 is less than 3.4. Automatically this may be less than, and also observe this number. This 10 raised to the power of 10 is less than 10 raised to the power of 12. This is a common sense. So obviously this number is less than this number. Simply you can tell. So 3.4 is greater than 2.7, and also 10 raised to the power of 12 is greater than 10 power 10. 3.4 into 10 power 12 is greater than 2.7 into 10 raised to the power of 10. So up to here this exercise is over for you. In the next class I am going to explain the laws of exponents, very important concept. So up to here all of you listen and write the notes. Okay, good day to all of you.